Hello class, this is your instructor Nicole Lytle-Kosola, and we're going to talk about Chapter 12, Acquiring Information Systems and Applications. In this chapter, we're going to introduce the idea of project management. Project management is one of those things that you could take a whole course or a whole degree in, but we're going to touch on that a little bit here. We're going to look at how organizations plan for and justify their IT acquisitions. What are their strategies for actually acquiring applications? And we're going to touch on some systems development methodologies, including the traditional systems development lifecycle. It's called the SDLC. And what are some other alternative methodologies? And then we're going to end with vendors and software selection. Okay, so a project is really a short-term effort, usually by an effort by a group to create some kind of common goal. And because your book is business focused, right? They talk about it being creating a specific business related outcome, but really you can have projects, all kinds of projects. Information systems project management, it's a directed effort to plan, organize, and manage resources that bring about successful achievement of specific information system goals. And every project has what are called these triple constraints: cost, schedule, and scope. Each one of these, for a project to be successful, it needs to come in, under or at cost, within the schedule that was set for it, and then of course the scope of the project can't have expanded over time, which tends to happen. So this image just depicts the fact that when you have a project, particularly systems development type of project, there tends to be a lot of different views on what the project is and what it should do. Okay, so you can see that, how the customer explained it, how the project leader understood it, how the analyst designed it, how the programmer wrote it, how the sales executive described it, how the project was documented, and they put that in there because a lot of times for systems development, if it's really, really bad, they won't document the system itself. They won't, maybe there's not a whole lot of user documentation, stuff like that. What operations installed, and so obviously this is something that's not, that's not going to function correctly. How the customer was billed, how the help desk supported it, and this is actually what the customer really needed. Okay. And so there are ways of minimizing this type of misunderstanding, and we'll talk a little bit about some of those. Okay, the project management process in and of itself has 5 phases. You have project initiation, where you're defining the problem that the project is intended to solve and the goals that the project is to achieve. You have project planning. Every project objective and every activity associated with the project is identified in sequence. So you go through, you're figuring out what the cost, the scope, all of that stuff in the planning phase. Execution itself, that's where you're actually moving forward with the project. Project monitoring and control, the project manager or project leader is in charge of making sure that the project is moving forward smoothly. Not every group or project would move forward without somebody making sure that all of the milestones are met, making sure that the project doesn't go astray, doesn't go over cost, time, things like that. And then of course you have project completion. It's when it's done and when it's formally accepted by the organization that it was created for. So project completion, if you have a third-party software development project. Project completion would be where the final product is handed over or presented to the client. Okay, so for organizations, when they're planning for and justifying these types of applications, organizations have a limited amount of resources, just like people do, most of them anyway. And so they have to figure out what projects are worth our time and our money to invest in. Okay, and so they have to analyze, what is the actual need for this application? Is this something that's going to benefit the organization, or is it something that one of the managers of one of the departments just wants? So each one has to be justified, and usually it's got to be in terms of costs and benefits. One of the things about some of the systems that we've talked about over the quarter is that things like CRM, customer relationship management, where you are improving the customer experience, being able to put up quantitative benefits of that. How do you put a dollar sign on customer satisfaction, right? That can be hard, and so sometimes the justification for some of these applications can be a little bit challenging. And most organizations have something like an application portfolio. What they call it is probably going to be different from one organization to another, but it's going to be a collection of projects and applications that they have within the organization. So what do we actually have right now, and what are some of the potential applications that we have our eye on, right? Are we looking at a brand new ERP system? What's our time frame for implementing something like that? That would all be in the organization's application portfolio. Okay, so with the systems planning process, you start with the organization mission and an assessment of the business. So what do we have existing in the business? Is there a need for additional technology, keeping up with our competitors, something like that? When we talk about the organization mission, what generic strategy does the organization support, right? When we mentioned Walmart yesterday. Walmart has that low-cost strategy, and the information systems that we decide to implement should support that strategy, right? And that all goes into the organizational strategic plan. You have the current architecture, and then together you have a IS strategic plan, which from that comes a new information technology architecture, the operational plan, and then of course the development projects. So like I stated earlier, you have that organizational strategic plan, and it's stating the overall mission and the goals for the organization. Your IT architecture looks at the way that the organization's information resources are used throughout the organization to accomplish its goals or mission. And then both of these together go into that IT strategic plan. Okay, a lot of companies, particularly large companies, maybe some of those medium-sized companies, have what is called an IT steering committee. An IT steering committee usually has mostly executive level managers, although they're all managers. And if it's a good committee, a good balanced committee will have representatives from all different areas of the organization. And the IT steering committee is the committee that new projects and software or information technology would have to go through. for it to get the green light to actually be something that the organization invests in. Okay. For your operational plan, it has the mission, right, of the company, the IT environment, so just kind of a general summary of the information needs of the organization as a whole. What are the objectives of the IT function? Now, we all kind of think we know what the IT function does within an organization, but depending on the organization, they may have different needs. The constraints of the IT function, so your IT department, what can they do and what can they not do? Some IT departments have individuals in them that can develop software from within the organization. Not every company has that type of brain power, so you got to know what your IT department can and can't do, because if you decide to implement a system that needs brain power that you don't actually have in your organization, you're going to have to work out some kind of outsourcing to get that, function from outside. You also have your application portfolio, which I mentioned before, and then your resource allocation and project management, which is generally who's going to lead what project, what's the team going to look like, what resources are we going to allocate to a particular project, what money, what staff, etc. Okay, so when it comes to evaluating and justifying these types of investments, you have to look at all of the benefits and costs. When you're assessing the costs, there are two types of costs. You have your fixed costs. These are the costs that remain the same regardless of the change in activity level. So the purchase price of a particular system may be a fixed cost. The total cost of ownership takes into account those fixed costs, but also you have to look at, after we get the system installed, what type of maintenance do we need? What type of training do we need to provide our employees so they become proficient in using that system? Those types of costs would go into that total cost of ownership. It's you could sort of compare it to buying a car. When you buy a car, you don't just take into account the payment on the car. There's a lot of other costs that go into that, including things like yearly registration, maintenance for the car, insurance, stuff like that. When you're assessing the benefits or the values, one of the harder types of benefits to assess, like I mentioned before, is these intangible benefits. Things like customer satisfaction. How do you put a dollar sign on that? These are benefits that are probably very desirable. They can be difficult to put to actually put a dollar sign on, and so having to present a system that with those types of benefits can be a challenge. And then of course, in the end, comparing the two, right? And the costs definitely should never outweigh the benefits of any investment. So when you're doing the cost-benefit analysis, there are some tools, and you're probably familiar with some of these tools from some of your either finance or accounting classes. Net present value, it converts the future values of benefits to their present value equivalent by discounting them at the organization's cost of funds. The return on investment measures the effectiveness of management in generating profits with available assets. So if you invest $2 million in a system, what are you going to get in return, usually over time? Your break-even analysis, you're looking at how long is it going to take you to make back the initial investments in the system. And then the business case approach is where you are looking at specific scenarios that this particular system can improve or make better. could be something like, you know, what are some of the issues that we have managing customers now? And you go into some of those scenarios. Maybe you actually get some quotes from customers that, you know, how these particular shortcomings of the company, you know, hurt their relationship with the company. And then you talk about what the system can do to improve that. So there's different ways of acquiring applications. You can buy applications, this idea of off-the-shelf approach. It's sort of like walking into a Best Buy and or the bookstore and purchasing some software, taking it home and installing it into your system. Off-the-shelf applications are usually kind of generic, and you can have off-the-shelf applications for a particular industry, like the auto mechanic industry. There's certain costs that go into billing a customer for auto mechanics. You have your parts and your labor. It's pretty standard across that industry. So there are applications that that are for use in that particular industry. And then you have things like Microsoft Office, which is sort of vertical market software. It's used across many businesses, and it's used usually in its kind of generic form. You take it, you install it, you put in a couple of prompts when you're installing it, and then you start to use it, kind of thing. You can lease applications. When you're leasing applications, you don't actually own the application. You are, you're leasing it from somebody else. With this idea of software as a service, oh my God. So with software as a service, the vendor themselves, they host the application. Usually it's going to be cloud-based, so it's going to be using the internet, and you access that software over the internet. You pay for what you use. You don't have to worry about installing the software, running it on your own systems, any updates, things like that. Open source software, we've talked about open source, right? It's free. You can go online and see any of the code and make changes to it. When it comes to service, you're probably still going to have to pay for any type of business level technical service. And then outsourcing, right? You bring a company, a third-party company in to develop an application for you. This is going to be one of the more expensive ways of doing that, particularly if you're doing a lot of customization of the software. And then of course developing the applications in-house. If you have the brain power to do it in the organization, you can have that done. It's going to be less expensive than some of the other options. Okay, so when we're looking at this idea of software as a these application service providers. An application service provider, again, it's here kind of in the cloud. Different customers, usually businesses, obviously this is kind of business focused, access their applications and have their own database for their data. Okay, so that's application service providers. For this idea of service as software as a service, all the customers are using the same application, and they have a shared kind of data center where everybody's information is in one large database. The thing about these types of applications, software as a service, usually your vendor is going to specialize maybe in one type, in a type or class of software that might be interesting to a particular industry, meaning that if you're customer A, customer B and C might be your competition. Okay. Now when we're thinking about the software development process itself, there are some methodologies that are out there. The SDLC, Systems Development Lifecycle, is kind of this traditional developmental method. It's used for large-scale, mission-critical type of projects because it's very document-heavy. It can be very cumbersome. And so it really is, it's the methodology you use when, you're implementing a system that's going to affect the entire organization, or that's going to, is a key part of your operations. Okay, this is looking at the SDLC process itself. You have the business need for the project itself. Goes into that systems investigation, where you're deciding, are we going to invest in this or are we not? So you have what's called a go or no-go decision. Once they decide to move forward with it, they go into systems analysis, where they're deciding what is our deliverable, what is the functionality of the system that we are going to focus on, who is our core users, right? And what are the user requirements for those users? So what do the users need to have for this to be a useful and productive system for them? You have systems design. From systems design, you have a technical specification of the system. The system's design should be detailed enough so that it can go from the designer to the programmers, and the programmers will understand what the system is supposed to do so they can actually create it. Once you do programming and testing, you're building the system, you're testing it to make sure that it's going to meet the needs of the organization. You're going to implement the system, and then of course you have your operation and maintenance at the end. And it talks about some of these supporting tools here. The joint application design, or JAD sessions, and case tools. Okay, so we kind of looked at all of these different pieces. And again, like I said before, with the SDLC as a methodology itself, some of the major advantages, there's a lot of control. The organization has a lot of control over the project. From every phase, when we talked about those 6 different phases, every phase has to be signed off by the managers that are the managers that are in charge of the project, or that are the stakeholders, major stakeholders. So it has that level of accountability to it. You move as the project team member or the project leader. You get sign off to move to the next phase. If your managers or stakeholders come back and say, wait, that's not what we wanted, you can come back and say, well, you signed off on it. Here's, this is the document that you signed off on, and we're going by this. This is what we're using. Possibly some heavy error detection in this particular type of methodology, because again, you are being accountable at every phase with all of the documentation from that phase, and you have to be accountable before you move forward. Some of the major drawbacks: it's not very flexible. You go from one phase to another. It's actually called the waterfall methodology, because if you think about a waterfall, you never go back up the waterfall. Everything always flows forward and down. Once you move from one phase to another, there's no going back. It's very time consuming and can be extremely expensive because it's very document heavy. There's a lot of people that are involved in it. Time consuming. If you have a very quick deadline for a particular project, this is definitely not the methodology to use. And once you have user requirements in place, it discourages any change moving forward. So once we decide this is the functionality we're going to focus on, down the line, if managers want to add functionality, they can't do it at least within this this particular project. Maybe the next iteration of the software or something. Okay, so we'll look at each one of the parts of the SDLC in a little bit more detail. The investigation part, you're starting with what is the problem or opportunity. What is the different levels of feasibility? So in the feasibility study, is it technically feasible? Is it financially feasible? Right. So there's a lot of different feasibility levels that an organization needs to go through that kind of feed into that decision making process. Are we going to move forward or are we not? Okay. They talk about, go or no go, but there's actually like 3 different options. So you can do nothing and just continue with your existing system, modify or enhance your existing system, or develop an entirely new system. And so that decision should come out of this phase of the project. I mentioned technical. I said financial. It was economic feasibility. Organizational feasibility has to do with the organization and its ability to access the project. Behavioral feasibility looks at some of the change management and human issues that any new project is going to have to face. Do you have the skills? What skills and training needs are you going to have? If it's a project that is going to create a major change in the way we do business, how are we going to manage that change? Because when you have a project that has failed, it can fail in more than just it doesn't work, right? It can you can have a system that works beautifully, but it's over cost, over time, the triple constraint. But also you can have a system that it isn't actually what the users need, or is a system that the users have decided that they don't want to use, and maybe they refuse to use it. They find workarounds, things like that. In your systems analysis, this is where you're starting to look at the problem that it plans to solve with the system. You're gathering information about your existing system, and then and from that existing system, you have to find out, what are the requirements for your new or improved system. From this phase, you have a set of systems requirements or user requirements that come out of here. The system analysis is extremely important because once you have those user requirements is kind of like the functionality of the system. With the SDLC methodology, once you have those user requirements and they're signed off on, the functionality of the system doesn't change from that point on. With systems design, you're looking at how the system is going to do what you want it to do. So the deliverable from your systems design is your technical design, where you're looking at the system outputs, inputs, and user interfaces. What hardware, software, databases, telecommunications, media, personnel, and procedures are you going to need for this system? And sort of a blueprint of how these components are integrated. So, it's going to come out with an architecture, a brand new architecture with the specifics of the system, what hardware, software, all of that, and how those pieces are going to work together. And again, it should be sufficiently detailed so that the programmers in the next phase can take that document and build from it. Okay. One of the things that happens to many projects is this idea of scope creep. You have managers that after the project has been initiated, they decide that there's other functionality that they'd like to add. that can cause problems with that triple constraint. So you add functionality, it's going to increase the cost, it's going to increase the schedule, it's you know, obviously increasing the scope. So that scope creep has to be controlled by the project manager. They have to find a way to discourage those types of that adding of function at, you know, particularly after the user requirements have been signed off on. And then programming and testing, where you're actually building the system, you're writing the code, and then of course once the system is done, and actually testing can take place in different ways. You can do testing of pieces of code as you're building. You can do you should definitely do testing at the very end when the whole system is complete, to make sure that it does what it's supposed to do and that you get the results you're supposed to. So what does the output look like? Is this what it's supposed to look like? You know, what input is it taking? Things like that. Testing is where you're trying to get rid of bugs in the code. And then, of course, implementation of a system. Organizations, when they implement different systems, there's 4 conversion strategies, 3 that are used more extensively. Okay, your direct conversion is where you basically shut off the old system and start up the new system. It's probably the riskiest of all of the implementation strategies, because what happens if the new system doesn't work? What if it crashes? You know, your pilot conversion. This is where you're introducing the new system in parts of the organization. So maybe if you're a retail location if you're a retail organization like Target, you implement the system in different retail locations. You test it to make sure that it works in each one of these systems, and you sort of expand your implementation from there. Phased conversion is where you are implementing the entire system, but you're not implementing all of the functions of the system. So you're introducing, you know, maybe you have some higher level, you have the basic functionality that's available to everybody, but some of the higher level functions are not available, you know, until you decide and usually until you make sure that the basic stuff works well. Okay. Parallel conversion is where you're actually running the old and the new system at the same time. It's going to be one of the safer ones, but it's not used very often in practice anymore. Once the system has been built and implemented, has been tested, you have operation and maintenance, which comes after. You might have audits that assess the system's capabilities, make sure that employees are using the system correctly, and in general, there's certain maintenance that needs to be done. You're going to have further debugging where you're finding issues. No system, especially large-scale systems, are perfect. There may be updating of the system that comes along, adding new functionality, new versions of the system, things like that, and then just general maintenance. You could be adding new features without actually disturbing the operation of the system itself. There's alternative methods for systems development. Prototyping is where you're taking the user requirements and you're actually building what's called a prototype, or sort of a model of the system. You use prototypes to get user feedback. So the managers, you show them the prototype, you get feedback. Is this what the user the user interface should look like? Is this what the system should be doing? These types of meetings while you are creating or building the system or designing the system really tends to create a better outcome at the end. Your joint application design sessions, your JAD is a group-based tool for collecting requirements and creating designs, which is JAD sessions are used during the Rapid Application Development Methodology, or RAD. You have usually meetings with managers, users, project team, and you maybe bring out prototypes, talk about the system, and get feedback to move forward. Okay. Integrated computer assisted software engineering tools, your iCase tools. They provide links between your upper and lowercase tools. Your agile. Actually, let's talk about RAD. RAD itself, it has special tools, and with RAD you have this what's called an iterative approach, so that you are doing small parts of the system and you're going through all of the whole systems development cycle with over and over again with different parts of the system. Maybe it's different functionality, whatever. But it has that iterative approach to it. Agile methodologies. Agile methodologies were actually developed, the methodologies as a whole were brought together under this umbrella of agile development back in the 90s. And the idea of agile development is that you have very rapid iterations, and that because of these rapid iterations, you have to have frequent access to your users and your managers. So you have to be able to get feedback from them maybe daily or weekly. And with older systems, SDLC types of system projects, that was not the case. And user development, it's where you're developing it in-house. You have the users themselves, with the brain power, they're actually developing it. Component-based development, where you have different components, it could be, different pieces that come together for that particular application, or you're developing it in pieces that, maybe can be used together. Object-oriented development is kind of a different way of thinking about systems development. You don't actually start with what is the task that we need to perform, but the aspects of the real world that must be modeled to perform that task. So it's kind of a different way of thinking about the problem itself, sort of from the beginning throughout the end. So when I talked about SDLC and the fact that it has that waterfall idea, right, that you move forward, always moving forward, never moving back, the Rapid Application Development, or RAD, you have this iterative development where you are constantly going through these iterations. You develop, you have your requirements, you design, develop, test. You have user review, and then your JAD session meetings where you're getting additional requirements and then moving forward. When it comes to organization, vendor software and selection, so your organization has decided that it needs a new finance system. Where can we get that system, right? This is kind of a 6-step process. You're going to identify the potential vendors who makes this type of system, who's kind of on our radar. Where are the different ways that we could actually get the system. We can get somebody to make it for us. We could get it off the shelf, maybe software as a service. In step 2, you're determining the evaluation criteria. So what do we need this system to do? what do we need out of a vendor relationship, right? Are we going to need them to develop the system and provide training and maintenance afterward? Can we do some of that sort of end additional maintenance and training in-house? So you kind of determine the criteria to evaluate the proposals that you'll hopefully receive from vendors. You send out what's called a request for proposal, and when we talked about the forward and reverse auction tools, we talked about the idea that a request for proposal was a reverse auction where you have one buyer who's sending out requests and hopefully getting sellers to send in proposals for how they would provide that particular service. Step 3, you're going through and you're looking at the different vendors and the packages or the proposals that they give. Step 4, you're choosing the vendor and the package. Step 5, you have to negotiate a contract. And step 5 should not is one of those things that when you go, if you haven't had your business law class, your teacher will talk about the importance of a contract and writing a good contract, because if there are any disputes down the line with this new relationship you have with this outside vendor, the contract is the terms of the contract are what are legally binding. So it's important to make sure that you get a good contract. And then of course, step 6, you're establishing what's called a service level agreement, or SLA. It's a formal agreement. It's going to specify how the work is divided between the company and the vendor. So who's doing what, how are they working together, etc., etc. Okay. So that is chapter 12. I'm going to go ahead and